right, so let's start with what is data? Data is the information collected through observation. This can take many forms. Maybe this is a direct observation, like you going and grabbing GPS points from around campus to make a map. Or maybe it's through a survey or census, like the US Census Bureau collects. Or maybe this is satellite observations, like aerial imagery. In a GIS, this is both the layers within your GIS, which contain geometry that you view on the map, as well as the attributes, which contain more detailed information about the contents of your points, lines, and polygons in your map. This also includes things like metadata, which is data about your data. Data can be broadly divided into quantitative and qualitative. Quantitative data is values based on things we can count and measure. This is sometimes collected through things like surveys, land use observations, or infrastructure observations. This data tends to be tangible in that it's capable of being perceived, especially by the sense of touch. Qualitative data, on the other hand, are values based on our perceptions, observations, stories, and experiences. Often we get this through things like interviews or other types of observations of participants. This data tends to be intangible, meaning that it's abstract in quality or attribute. Let's quickly go over some definitions and some things you may want to consider about your data. First, provenance. This is where your data comes from. Who collected it? Are they a valid entity? Do they have specific aims? And how did they collect it? Is that data reliable? Do the producers have QA, that's quality assurance, or QC, quality control credentials, or a reputation for doing so? Places like the US Census Bureau, for instance, have a lot of QA and QC to make sure that that data is accurate. If you're just going around and collecting points with your phone, you're maybe not checking for quality assurance. But you may, and that would make that data fairly reliable. Next up is extent. What is the area that the data set covers? Is it just, say, the University of Oregon campus? Is it the whole city of Eugene, the whole state of Oregon, the whole United States, or the entire world? Next up, we have to consider our resolution. Often we think about this when we're talking about raster, when we think about what size our raster cells are, but it can also apply to the resolution of our vector data as well. And we consider this when we think about how many vertices there are in our data. We talked about this earlier when we talked about data scale. Next, we have metadata. This is data about your data. This tells us things like what time period the data represents, or if there's any missing data. Next, we have format. What file format does the data come in? Is it a shape file? Is it a Word document? Is it a CSV, a comma separated value? And will you have to change it to make it useful for yourself? Lots of data comes in CSVs. These can be opened with Excel, but when we bring that into GIS, we might want to make it and save it as a shapefile. Data are often structured as tabular or spatial, and they have metadata. We already know a lot of this. Tabular data is where the values are organized in rows and columns. Spatial data is where those values can be mapped to a geographic location. And finally, metadata is data to describe your data. Let's talk about that in a little more detail. So this is an example of a metadata. This is a README file that tells people how to use my data, in particular from my dissertation research, how to navigate it, and how I collected it. At the top, it tells us the title of our data set, my information as the author, where I'm located, and how to get in contact with me. It tells you when I collected this data, which I did in 2017 and 2018, the geographic location of my data collection, which happened in Pennsylvania, and who supported or sponsored this data collection. This was sponsored by the National Science Foundation and the Society of Women Geographers. It tells you how to cite my data in case you want to use it for yourself. All of the files that are included with this data, so there's a CSV, there's a text README, that's what we're looking at here. There's a second CSV, and then there's a zip file, which contains a lot of screenshots. I explain what that zip file is. I explain how all of the different files are related so that you can go and read this file and know how to use my data. What types of data are there? We have all sorts of data that you can use in GIS. From cultural to science to finance to demographic to weather, environment, transportation, and geography. This isn't an exhaustive list, but you might be able to think of ways in which to fill these in. For instance, I started here with weather data, which you can get from NOAA, or the National Weather Service, part of NOAA. But we might be able to think about other places where we could get data on these other different topics, such as demographics. Where might you find that? Watch some of the other videos that I included in this week's module to see where you might get demographic data. Finally, let's talk about big data. We've heard a lot about big data, probably because it's one of our biggest challenges in the 21st century, but also one of our biggest opportunities. Big data can come in all sorts of things, but it has these three characteristics: high volume, high velocity, and lots of variety. Volume relates to how much data is generated. Big data is huge. It comes in kilobytes or terabytes. Often it's saved in records, tables, or files. It comes from all sorts of different transactions on and offline. Velocity. This data comes in fast. It's generated in real time. It has high speed. It comes in streams, batches, or bits. And then it has a lot of variety. It's both structured and unstructured, meaning that it sometimes makes a lot of sense and sometimes it's a big mess. It can contain things like images and videos, things like text and other human-generated information, but it can also include machine-generated things. There's a whole class in our department called Geography 281, the world and big data, which gets into the specifics of big data. Finally, you can create your own data, and we'll talk about this a little bit later.